Good day, everybody, and today I am going to tell you about a beautiful software which is called Geogebra. This is actually this Geo comes from the first three letters of geometry, and Gebra comes from the last words of algebra. So these two together is given the name Geogebra. Now this is such a nice software that nowadays teaching and learning maths in school level is followed by many countries. In our country, of course, students are using this, some but very few students, I suppose, because formally it has not been, so far my knowledge goes, has been adopted in any of the curriculum. But nonetheless, this particular software, which is freely available, is very useful in learning maths and doing experiments by varying several things in an equation or some parameters you can vary to see various things. What is so special about GeoGebra, according to me, is that it picturises everything in a very nice way. Okay, so we will learn about that, and I will try to go step by step. And not only that, this GeoGebra, one should not understand that, or one should not feel that it is only restricted to be used by school students. It is very much used by postgraduate students, undergraduate students of any curriculum, and also for research level. Anyway, but those who are really not, those who have not yet been initiated to this particular beautiful software, I thought I will make some basic lectures on this particular topic so that they will discover more and more powerful things associated with GeoGebra. For example, you can do two-dimensional geometry, you can do three-dimensional, you can do vector algebra and whatnot, statistical data analysis, things like that are very important component of this particular software. As I told you, it is a free software. Now the question is, if you have not installed this software in your laptop or PC, I will first tell about that and then I will come back. So what you do is this: you suppose go to your web browser, say Google, and then you can write this, you can type this important thing here, that is the, if you see this sign, if you write here, you hope this address in your Google browser, you will be given this window where you can go to the last line where new to GeoGebra, want to sign in, you have to sign in with your Google account. Okay, and maybe they will ask about your password and few things about that. Fill up those and your GeoGebra will be at your service in your PC. That is the whole idea. Clear. So you please do that. Get GeoGebra installed in your PC. After you have installed the GeoGebra, then don't forget to make a bookmark here, so that whenever necessary you can use it. For example, I have made a bookmark here, and this is the page. You will be this window will come up. So what you have to do, you have to install GeoGebra, then you make a shortcut by using bookmarks, etc., and you get it here, and whenever you wish you just click that and this particular window will come. Now GeoGebra, when you work with it, you can have various flavor in which way you want to carry out your work. You see, in default, it rather encouraging you to use this mode, start calculator mode, which is highlighted also with this color. Therefore, I will also go by that. Later I will take, for example, there is one called Geogebra Classic. That is another good platform. Same GeoGebra, same thing, but in a different appearance in the window. I'll talk about that later. But since I prefer this one, and also I will encourage to use this one for reasons which will be apparent soon. So you press the start calculator mode. And don't forget that you should have a reasonable fast internet connections. So I am doing it now online. Are you getting? So this is the thing. Now here this total screen is divided into two parts, major parts. One is this left hand side, this area, and this right hand side where a nice graph paper is there with x and y axis. And the good thing is you can change the scale of this thing at the click of your mouse. Clear? You can always do like this. So you select some scale. Now what basically we'll be doing is that on this left hand portion you can add instructions in these lines. Okay, and whatever you want to do, you write it here, and GeoGebra will, if the command is correct in its syntax, then it will execute that and will give output and display in this right hand portion of the graph paper. Graphing is the choice. There are other options, but graphing is very much used and useful to us. Okay, therefore this is what we will be doing. You understand that here on this left hand side I will give instruction and GeoGebra will execute that and will give you output on this graph paper. And as I told you earlier that GeoGebra picturises everything, so learning maths become really enjoyable. Now let us start without much ado. Is this one, and what is the, we will start in fact with coordinate geometry. Okay, and those who are conversant with that, it will be much easier. For example, in coordinate geometry we start with point with its definite coordinates. For example, you give a point, the instructions are so simple, as you can see. The coordinates of a point 1, 2, you simply write like this as you write in your paper, and put return, and you see a point has been here displayed at 1, 2 coordinate. Okay, and okay, so it has given a name A, as you have suggested, and it will put the dot or the point in the appropriate place. Clear? Now in GeoGebra, whatever you write, for example this point A, it will be treated as an object. Try to put it in your mind that everything is there in the object. So A is an object. Now there are 3 dots associated with every instructions, as we'll see further, but let us examine what it means. If you just select this 3 dots, what you can do? You can go to the setting window where about the point A everything is registered. For example, A is a point with coordinates 1, 2, and if you like you can change its color. For example, it was blue, you have seen, you can make it red, suppose like this, and you can also change the appearance of the point which was like this to suppose this, and you can also play with the point size. And if you look at the point now, where is the point gone? Oh, there is one thing. Here this point is now shown as A. You see, there will be, after the instruction is correct, there will be a circle here where if it is colored, the color will be the object color. It shows like this, and you can deselect the points. Suppose you press it, make it white, the point will not be displayed here. Sometimes what happens is that you have so many curves plotted in this graph paper, but you are interested in one graph only, then others you hide them. So this point is really there, but it is being hidden now. So you select it and your point is here. So I like the in default whatever was the setting. Let us do that. Color is somewhat like blue, I hope. And the style is this dot. Okay, we have. So it is no maths, but only thing about the point you can do several things. So this is the single point we start with. Okay. You can create another point like this, B, and it could be say 3, 4, and another point B, and put return. It will put the name B, and another point is obtained. Is that clear? So you can create as many points as you can. Okay. Now this step, next step is I can, suppose somebody types like this, C is a point, and you write it like this, A comma B. Now the big question is what your GeoGebra is going to do now. The question comes, GeoGebra can't help this situation because somebody is asking to put a dot here, point here, with coordinates A and B, the values of which have not yet been supplied to it. But GeoGebra, the software is made in such a way, then presumes that, okay, perhaps the user is trying to create a point C here on this graph paper, with coordinates A and small b, and perhaps A and B he would like to vary. Okay, that is what it thinks. For example, I put a return to it. Whether it does something, yes, it does so many things. It presumes that A and B, which earlier I have not defined, it presumes that, okay, he would like to change A and B, so it creates this two additional lines which are called sliders. Okay. For example, the value of A can vary from -5 to +5. If you push it here, there, it will change. Similarly, B value can be varied like this. In default, these bullets are set at 1. -5 to +5, -5 to +5, and okay, at the beginning GeoGebra set it at 1. So it writes A equal to 1 now, B equal to 1 now, and your point C now at 1, 1. Indeed, it is at 1, 1. Got the point? So these are called sliders, and sliders are nothing but variables whose value you can now select. Okay, and it looks like if I vary B, if I vary suppose A, small a, what the point is going to do? X coordinate you are changing, B is at 1, and your point is doing like this. Clear? Now I did not tell you another thing which I am now going to tell you. For example, look at point 1. So you have got the idea about these variables. Whenever there will be some unknown variables, GeoGebra will presume that the user want to vary that variable, so it gives you a chance to vary the variable with some limits. Here between -5 to +5, you will be able to vary that. And these ranges, of course, can be edited, as I told you. For example, these two are also objects, and it is there. And if you press this, select this, then this object will appear in the graph paper, which I don't like, because I don't want to make my working space, that is the graph paper, too clumsy. So let it be acting silently here. So you have understood this, but this is nonetheless an object. Let us go to this slider settings. Here you see its name is a -2 something is there. Slider is some minimum value, maximum value, which can be changed whatever value you like, -10 to +10. You type them, and it will be doing the variation in the way you like. Okay, so each slider is also an object, and you can change the range for each slider. In this case there are 2, and similarly for B you can do that. Clear? Is that very simple? So in case you define a point like A, comma B, automatically GeoGebra will create 2 sliders, and it will place it just before it, obviously, and then you can vary this. Now one thing about this point A or B, whatever it is, you suppose come to the point, go to settings. There are several options here. Show the object. So the object means it will print that capital. So the object means that dot will be placed there. So label means capital A will be there. Okay. And there is another square here. Fix object. I want to tell what is this fixed object about. For example, now this point A is not a fixed object. It simply means that you can place now A wherever you like, and if you change its position, here the coordinate gets also changed to that. So the unique position dictated here will be placed here. This you can type it, change it, or you can place it anywhere else you like. The corresponding changes will take place. You need not worry about the current position will be always shown here or there. Similarly, B, you can move it and change it. However, if you go to the settings of, once again to the setting of the object A, that is a point, and if you click fix object, you will see now this point you cannot shift even if you try, because you have defined this position of the object A to be fixed in your graph paper. It will not be. Okay, so this is the thing. Okay, now about the slider, once again you see there are two play symbols here. Okay, it is so obvious that if you change it here, the values of A, B coordinate remaining same, it will move along this horizontal line at B equal to 1, that is Y coordinate, it will move, and you can change that. But this play options shows you that automatically it will change from -5 to +5 to see the locus of the point C if you vary its x coordinates. Simply like that. What the point? Very simple and nice too. So you get the idea of locus of a point when its x coordinate is being varied. That's all. And you can always, of course, stop it, and at whatever position it is, that value of A will be shown here. Cool. There is another options I will like to tell you. I am now going to the setting of the object C. Show object, show level, that is the capital C will be printed, and object, that dot will be there about the point. And there is another interesting option that is called show trace. Okay. What is the show trace business? It is like this. If you now play this variable A, it will keep trace of the point and it will indeed show you the locus of the point. Okay. As it varies from -5 to +5, it will do like that, and it will oscillate. In default, that can be changed. You can increase it only for once. That we will discuss later, but the idea is like that. But one important thing is, I would like to tell, you can don't trace it, and so trace is the point, actually is the locus of the point, C is the locus of the point. Now as you are varying A, I have now go to the setting of A, and it is a slider, and you see it will vary from -5 to +5, this increment. This increment in default is very small, that's why you are not seeing the points, because maybe 0.1 is the in default the increment is. Okay, 5, 5.1, 5.2 when it increasing like that. So increment if you make say as 1, so it will start from -5, then -4, -3, in that fashion it will change, then things will be and once again if you play this, what the C point is doing is going in steps of ones from -5 to +5. Is that clear? And if you also want to see trace now of this point, then click trace, and it will it will keep the position of the point C, whatever position is it occupied before. Okay. So you have understood what is a slider, and slider, if you vary the position of a point, can be changed for example of this point and so on. Okay. Now as you can see that I will this thing. Now suppose I say that okay, I will now vary B. So it will move vertically up and down. Why it is doing so smoothly? Because the increment in this slider from -5 to +5 is very small, which you can once again make it say in steps of 1, like this. You go to slider and make in terms of 1, and then you say that this is okay, and play B. You can remove the previous traces, so it will be the locus of the point C, if you only vary B, will be a vertical line as expected. And now if you vary both A and B with the increment of 1, how the trace will look like is like that, and it will follow that the current location of the point will be always shown, Therefore you see you can do several things with a point. Now this pattern maybe it will be looking somewhat crazy, but nonetheless it does as per your dictates. You wanted to see the pattern if I vary A and B where they are at present, it will be doing this. This will be the locus of the point C, which is a bit complicated in its appearance, but nonetheless that is what the locus is. Therefore, my friends, you have understood the meaning of sliders, how to create points, and each one typed here is an object. A, B are objects. Sliders are also objects. They are variable, two variables, small a and small b, in this way, and so on. It does, of course, it means that suppose you want to clear all the traces, you just do some clicking here, all previous traces go, and you are left with the 3 objects here. Okay. Now lastly, I want to tell you these sliders can be also created separately. For example, you create a slider D for your future purposes. For example, you have created a slider D and you write a point, say P, and write it as D comma 8, D comma 8, this will be the point. Okay, and then this can be played D and just so this D can be varied, and you can, its position will change. So you play this here, and D value, and its position will be changing. So slider can be created at any stage whenever you feel, or even if you write some object with some variable which has not previously been defined, the GeoGebra creates sliders automatically. I hope I will stop here now, and I hope you have understood it, and we will go to our next lecture reviewing this and telling about the straight lines. Have a good day. Thank you.